this is the human lens. I'm drawing here human eye. This is human eye, pupil. Suppose that person can see the image up to 80 meter or centimeter. What is given? 80 centimeter. That person can see the image up to 80 centimeter. Means यहाँ तक वो image देख पा रहा है. But if the object is here, means beyond, beyond 80 centimeter, the object is, then that person is not able to see this clearly. Why? Because see, these rays are coming from, light rays are coming from the object and they are diverging before retina. तो retina तो screen है, retina पे अगर object का image नहीं आया तो that person will not able to see, because retina पे जो image आएगा वो ही जो optic nerve है वो brain तक पहुंचाता है. तो for this problem, because of this problem, that person will not able to see the image. Then what we will do, we just will diverge the rays by using concave lens. यहाँ पे हम concave use करेंगे तो ये क्या करेगा, यहाँ तक जो rays आए हैं वो थोड़ा diverge करेगा, यहाँ ऐसे, in this way. The rays will get diverge in this way. The rays will get diverge in this way. From here only it will get diverge and then it will get converge, so that the image will shift back. So that the image will get shift back on retina. I hope you have understood. And this is the correction of myopia.
This is the short explanation about for correction myopia. The question is, the far point of a myopic person is 80 cm in front of the eye. What is the nature and power of the lens required to correct the problem? So let's find its solution in detail.
Here the far point we have given. The far point of a myopic person is 80 centimeter. 80 centimeter means that person can see images up to 80 centimeter. अगर वो person images देख रहा है up to 80 centimeter, like this is the human eye. We know this is the human eye, optical nerve, and that person can see the distance up to 80 centimeter. Sorry, this is 80 centimeter. Means here that person can see the image. The image can see up to 80 centimeter. See, the object is here. Okay, I will show you. Like, suppose the object is here and the object is beyond 80 centimeter, right? That person can see only the objects up to 80 centimeter, but it cannot see, that person is not able to see the objects beyond the 80 centimeter. Why? Because the images, see, these are the rays, light rays, and these rays are converging here. Converging here means before retina and not on the retina. Since the image is forming before retina, means before the screen, that person will not be able to see that object which is at distant position. दूर के ऑब्जेक्ट्स उसको नहीं दिखेंगे because वो इमेज जो है वो before retina form हो रहा है. तो in this case we have to use concave lens. Concave lens will diverge the rays in this way. The concave lens will diverge the rays in this way, and after diverging, that will shift, the lens will shift the image on retina. इसमें क्या होता है, जब आप concave lens यूज करते हो तो concave lens is always help to diverge the rays, and after diverging again it will get converge due to convex lens, right? Lens, हमारा eye lens कौन सा है? हमारा eye lens convex है और वो rays क्या करता है? Converge करता है. तो यहाँ पे ये लेंस रेज जो है वो कन्वर्ज हो गए, वो थोड़े बैक शिफ्ट हो जाएंगे and then the image will form on the retina. I hope you have understood it. I will show it to you again. So according to question, we need to write the required thing was which nature of lens. So nature of lens is concave. We are using concave lens, and now we need to find focal length, means power. Power find करना है हमें अभी, means power कितने power का lens उसको use करना पड़ेगा. Remedy, as a remedy, how much power we will refer to that person to correct this problem. So what is the formula for power? Power is always reciprocal of focal length. So for finding power, you should know how much focal length is. Because we need to find the correct power, or we need to find the nature of lens and the power of lens required to correct the problem. As we know, power is equal to 1 upon f. Power is the reciprocal of focal length. diopter, right? But here we don't know how much focal length is. In that problem, focal length is not given. So first you need to find focal length. And how to find focal length? By using lens formula. What is it? I'm writing here. By lens formula, we will write f. 1 upon f is equal to 1 upon v minus 1 upon u. And in this, v is minus 80 centimeter. Why negative? Because the image is forming on screen, means the image is real and inverted, and also we are using concave lens, means the image is inverted and real. So we have written this is negative, and all inverted images, we know all inverted images will form in front of the concave lens, in front of the lens only. So we have taken it negative. In this myopic problem, always we are going to use value. I will write here. Yes, perfect. 80 centimeter is the right answer, but it should be minus, negative 80. Minus 80 centimeter, right? Because you are finding focal length, and focal length will be always negative in this lens, concave lens. ओके यू आपको यहाँ पे कंसिडर करना है इन्फिनिटी, क्योंकि प्रॉब्लम मायोपिया प्रॉब्लम है, एंड इन दिस प्रॉब्लम person can see nearby objects and not able to see the objects, distant objects clearly. तो यहाँ पे आपको infinity लेना है, object आपको infinity लेना है, and that also will be negative because object is always in front of the lens. So यहाँ पे आपने ये भी negative लिया. All the things we will substitute. 1 upon f is equal to 1 upon v means 1 upon minus 80 minus 1 upon u means 1 upon minus infinity. Okay, and since minus minus, I will write here plus. It will become plus. 1 upon infinity is 0, that we know. I have corrected, it's minus 80. And then you will write it's 1 upon f is equal to minus 1 upon 80 plus 0. Minus 1 upon 80 plus 0 means 1 upon f is equal to minus 1 upon 80. We are on that point. 1 upon f is equal to minus 1 upon 80 means that 1 upon f is equal to minus 80. Correct. Very good. F is equal to minus 80. So you can substitute this f's value in power. Otherwise, you know 1 upon f means power. Power means 1 upon f. So you can take the same value directly. Okay. So 1 upon 80 का value आपको find करना है. You will have to find it. Now this is 80 centimeter and this is 1 meter. You can convert it into 100 centimeter if you want. You can convert it into 100 centimeter. So same thing I'm going to do here. 1 means 100 centimeter हमने किया, ये हमने 80 centimeter में ही है, right? This was in centimeter and this formula is applicable for meter unit. This formula is applicable for meter unit. As we have the focal length in centimeter, we will use this formula 100 upon f. Do you understand it? क्योंकि सेंटीमीटर का हमारे पास कैलकुलेशन है तो हम इसको सेंटीमीटर में ही फाइंड करेंगे. सो पावर यू कैन गेट बाय यूजिंग द फॉर्मूला 100 upon f. 100 upon f. And here you will find it. 0 0 will get cancelled. 8 ones are 1.2.5. 1.25 diopter. So for correct the problem, we can refer to that person the lens of power 1.25 diopter. The lens of concave lens of power 1.25 diopter. That is the final answer. So you will write there. Nature of lens is concave lens and the required power of the lens to correct the problem is 1.25 diopter. Required power to correct the problem is 1.25 diopter.